Freeze it right there. Do you see it? That single pixel? Anomalous, out of place, wrong. Zoom in closer, closer, there. This is not supposed to exist. 47 days from now, an object currently hidden behind our sun will emerge from the cosmic shadows. And when it does, we'll know. We'll finally know. But here's what keeps scientists awake at night. What if we already know? Because this image you're looking at right now was taken 3 weeks ago. And if it shows what some researchers believe it shows, then everything changes. The stakes? Let me spell them out for you in the simplest terms possible. If this object is natural, it's rewriting the physics of comets, forcing us to tear up textbooks and start from scratch. If it's not natural, then we are looking at the first confirmed interstellar technology humanity has ever encountered. Either way, someone's world is about to collapse. The question is, whose? Science, markets, governments, or yours? But I'm getting ahead of myself, because this controversy didn't start with this image. It started months earlier, with an object that refused to behave. Let's go back to the moment everything began. March 14th, 2024. The Atlas Survey, Asteroid Terrestrial Impact Last Alert System, picks up a faint smudge in the constellation Ursa Major. At first, nothing special, just another icy visitor. Or so they thought. But then the numbers started coming in. And the numbers, they didn't make sense. See, when you discover a comet, there's a checklist, a predictable checklist. You measure its brightness, analyze the light it reflects, study its tail, check its chemistry. It's routine, it's boring. Except 3i Atlas wasn't playing by the rules. First red flag? The photometry. That's the science of measuring brightness over time. Every comet has a signature, a fingerprint of how it brightens and dims as it tumbles through space. 3i Atlas's signature was unusual, variations that didn't match known tumbling patterns, fluctuations that suggested what exactly? No one wanted to say it out loud. Second red flag? The tail. Now, pay attention here, because this matters. When you look at a comet, you expect to see a tail pointing away from the sun. That's basic physics, right? Solar radiation pushes dust and gas in the anti-solar direction. Simple, predictable, comforting. But multiple observers reported something strange with 3i Atlas. A glow, a shimmer, on the sunward side. Light, where light shouldn't be. Third red flag, chemistry. Spectroscopy, the science of analyzing light to identify elements, revealed something that made chemists do a double take. The signature of nickel, but without the expected iron signature that always accompanies it in natural bodies. Always. No exceptions. Until now. And the fourth red flag? Polarimetry. This measures how light waves are oriented after bouncing off an object. Every type of cosmic dust, every mineral, every ice formation has a polarization signature. 3i Atlas's signature didn't match the comet catalogs. It didn't match anything in the comet catalogs. 4 anomalies, 4 pieces that didn't fit. But here's where it gets interesting, because someone, somewhere, realized that this object was about to do something incredible. In late May 2024, 3i Atlas was going to pass Mars. Not just pass it, but pass it at a distance where the most powerful cameras humanity has ever placed in orbit around another world could photograph it. High resolution, multiple angles, the shot of a lifetime. Observatories prepared. Amateur astronomers cleared their schedules. Social media buzzed with anticipation. And then, nothing. Silence. Let's talk about what should have happened. Mars Reconnaissance Orbiter, MRO. This spacecraft has been circling Mars since 2006, equipped with HiRISE, the high-resolution imaging science experiment. HiRISE can resolve objects on the Martian surface down to 1 meter. 1 meter from orbit. Now, 3i Atlas was going to pass Mars at approximately 0.04 AU. That's about 6 million kilometers. At that distance, with HiRISE's capabilities and the right exposure time, We're talking potential resolution in the tens of meters. Maybe better. The European Space Agency's Mars Express orbiter was also in position. Trace gas orbiter. Even amateur astronomers with large backyard telescopes were ready. This was IT, the moment we'd get our first real look at this mysterious visitor. May 23rd. Closest approach. Nothing. May 24th. Nothing. May 25th. 26th. 27th. Nothing. Now, let's be clear. Space agencies don't owe us real-time data drops. Image processing takes time. Review takes time. Calibration, validation, peer review, all legitimate reasons for delays. But here's what made people nervous. The silence wasn't just long, it was specific. Other Mars Reconnaissance Orbiter images, released on schedule, other scientific observations, published normally, but 3I Atlas imagery, pending, under review, not yet available. And into that vacuum, rumors began to flow. Reddit threads exploded. Twitter, now X, became a battleground. Claimed leaks appeared and disappeared. Anonymous posts from people claiming to work at NASA, ESA, claiming they'd seen the images and couldn't believe what they showed. Were they real? Probably not. Probably just the internet doing what the internet does, filling silence with noise. But then, the amateur astronomers released their images. Now, before you dismiss amateur contributions, understand something. Modern amateur astrophotography is not your grandfather's backyard hobby. We're talking about sophisticated equipment, image stacking software that combines hundreds of exposures, and communities of skilled observers who've discovered supernovae, tracked asteroids, and contributed real data to real science. These people know what they're doing, and what they showed was unsettling. Multiple independent observers, using different telescopes, different locations, different software, all produced images that showed elongation, not a fuzzy round blob, not a typical comet coma, something cylindrical, cigar-shaped. Now, here's where we need to pump the brakes. Elongation in astronomical images can be caused by many things. Motion blur, tracking errors, atmospheric distortion, the way image stacking algorithms handle moving objects. But the consistency across multiple observers, that was harder to dismiss. And then, just when the speculation reached fever pitch, someone claimed to have the official images, the images that NASA and ESA supposedly didn't want you to see. Were they real? Were they doctored? Were they complete fabrications? By the end of this investigation, you'll have the tools to decide for yourself. But first, we need to look at what these new photos actually show. And more importantly, what they can't show. Because the camera can lie. All right, let's do this properly. You're looking at an image on your screen. It shows something. An elongated blur, maybe a structure, maybe just pixels pretending to be meaningful. How do you tell the difference? First, you need to understand how these images are made. When you photograph something moving against the background stars, a comet, an asteroid, anything, you face a problem. Long exposures blur the object. Short exposures don't gather enough light. So what do? You stack. Image stacking is brilliant. You take dozens, sometimes hundreds of short exposures. Then software aligns them, either on the background stars or on the moving object itself, and combines them. Result? You get the light-gathering power of a long exposure with the sharpness of a short one, usually. But here's the catch. The algorithms that do this alignment, they have to make assumptions. They assume the object is a point source or a simple extended source. They assume certain mathematical models of how light spreads. And when you're dealing with a faint, fast-moving object at the edge of your instrument's capabilities, those assumptions can create shapes that aren't really there. Deconvolution. That's the technical term. It's a process that tries to sharpen blurry images by mathematically removing the blur. It works beautifully. When you know exactly what caused the blur, it creates artifacts. When you don't. So, let's look at the claimed images one by one. Image set 1. Amateur stacked exposures from late May. Multiple observers. Elongation ratio approximately 3:1. Artifact risk, medium to high. Why? Because each observer used different stacking software with different algorithms. The fact that they all show elongation could mean there's real elongation, or it could mean all the algorithms make the same systematic error when handling faint, moving objects. We need more data to discriminate. Image set 2. Claimed leaked orbital imagery. Higher resolution. Shows what appears to be a distinct, non-spherical geometry. Artifact risk? Unknown. Why? Because we can't verify the source. We don't know what instrument supposedly took it. We don't know the exposure settings, the processing chain, nothing. Could it be real? Yes. Could it be fabricated? Absolutely. Could it be real but misinterpreted? Also, yes. But here's what's fascinating. Even if we can't trust the shape in these images, the physics might be telling us something else entirely, because while cameras can be fooled, spectroscopy doesn't lie, and the spectroscopic data. That's where things get really weird. Forget the images for a moment. Forget what you think you're seeing. Let's talk about what we can measure, because there are 7 anomalies in the data for 3I Atlas. 7 pieces of evidence that don't fit the standard Comet model. And the question we need to answer is simple. Are these 7 separate flukes, or 7 symptoms of the same impossible truth? Anomaly. Number 1. The sunward glow. Remember what I said earlier? Comet tails point away from the sun. Always. It's not a suggestion, it's physics. Solar radiation pressure pushes gas and dust in the anti-solar direction. Simple. But 3I Atlas displayed a persistent forward scattering glow. Light reflected toward the sun's direction, visible from multiple observing angles. Now, can this be natural? Yes. Large flat ice fragments with specific orientations can scatter sunlight in unusual directions. Viewing geometry matters. But here's the problem. This glow was observed across multiple weeks, across changing geometry. For natural scattering to explain it, you need a very specific set of conditions that just happen to persist at exactly the right angles, for exactly the right duration. Possible? Yes. Probable? Anomaly number 2, the nickel without iron problem. This one keeps chemists awake at night. In every natural body we've ever studied, comets, asteroids, meteorites, planetary cores, nickel and iron appear together. They form together in stellar nucleosynthesis. They bond together in planetary differentiation. They're inseparable. Always. 3I Atlas showed strong nickel emission lines in its spectrum, but the iron lines that should accompany them were either absent or far weaker than expected. Natural explanation? Maybe exotic differentiation in its parent body. Maybe unusual surface chemistry. Maybe contamination from an impact. Maybe. But it would require a formation environment we've never seen before, producing chemistry we've never measured before, in an object that just happens to exhibit 6 other anomalies. Starting to see the pattern? Anomaly. Number 3, polarization phase. Angle mismatch. When light bounces off dust particles, it becomes polarized, meaning the light waves orient in specific directions. The degree of polarization changes based on the viewing angle, the phase angle between the sun, the object, and Earth. Every type of cosmic dust has a signature: icy particles, silicate dust, organic compounds. We've cataloged thousands. 3I Atlas's polarization curve doesn't match any known cometary dust composition. It's not impossible to explain naturally. Maybe it's a new dust type. Maybe it's a mix we haven't seen before. But, again, it's another anomaly to add to the pile. Anomaly number 4, trajectory alignment and multi-planet timing. Here's something that made orbital dynamicists raise their eyebrows. 3I Atlas's trajectory brought it into the inner solar system at an angle close to the ecliptic plane, the plane where most planets orbit. Not exactly on the ecliptic, but close enough that its path brought it near multiple planets in sequence. Mars, then Earth, then Venus. Random interstellar visitors should come from any angle. The fact that this one's trajectory happens to thread through multiple planetary encounters could be coincidence, or it could be selection, natural explanation, absolutely possible. We have a small sample size of interstellar objects. Maybe close to ecliptic arrivals are more common than we think. Selection bias could be at play. We're more likely to discover objects that pass near Earth. But then you add it to the other anomalies. Anomaly number 5, mass trajectory stability, inconsistency. When comets approach the sun, they outgas. Water ice sublimates. The escaping gas creates a rocket effect, tiny thrust changes that alter the trajectory in measurable ways. These are called non-gravitational parameters. We can detect them. We can model them. 3I Atlas showed outgassing. But the trajectory deviations didn't match the expected non-gravitational accelerations based on its observed brightness and estimated mass. Either it's more massive than it appears, meaning it's denser than typical comets, or something else is going on. Natural explanation? Yes. Maybe it's an ice-poor, rock-rich interloper. Maybe our mass estimates are wrong, or maybe the thrust isn't coming from random outgassing. Anomaly number 6, repeated brightness fluctuations at non-harmonic intervals. Most tumbling objects show periodic brightness changes. Spin, tumble, flash, fade. Predictable. 3I Atlas's light curve showed variations that didn't fit simple rotation models. Flares, dips, changes that suggested either a very complex shape or something else. And finally, anomaly number 7, the silence, the institutional hesitation to release data, the delayed images, the careful language in the few official statements that were released. Maybe it's just bureaucracy, maybe it's caution, or maybe they saw something that made them pause. 7 anomalies, 7 puzzles. Are they connected? Do they point to a single, shocking explanation? Or are we seeing patterns in noise, connecting dots that don't form a picture? Because for every anomaly, there's a scientist with a natural explanation, and we need to hear them out. Let's play devil's advocate. Actually, let's play scientist. Because the mark of good science isn't just collecting anomalies, it's testing whether natural explanations can account for them. So, here's what the comet physics community is saying. For the sunward glow, Dr. Yuri Petrov at the Planetary Science Institute ran simulations showing that if 3I Atlas ejected large, flat ice fragments during an outburst, and if those fragments had specific spin states, they could produce forward scattering that mimics a sunward glow. Look at this. When you model particle size between 1 and 10 centimeters with high reflectivity, tumbling at specific rates, you get unusual scattering patterns. Is it a perfect match? No. Does it require some fine-tuning of parameters? Yes. But it's possible. For the nickel without iron chemistry, there's a hypothesis involving differentiated fragments from a disrupted protoplanet in its home system. If 3I Atlas is a fragment of a larger body that underwent partial differentiation, and if that fragment came from a nickel-rich layer, you could get unusual elemental ratios. We've seen hints of this in some meteorites. Iron meteorites with nickel content varying by layer. It's exotic. It's rare. But it's not impossible. For the polarization mismatch, maybe it's telling us about dust formation environments in other stellar systems. Maybe alien star systems produce dust compositions we've never encountered. That would actually be exciting from a scientific standpoint. It would mean every interstellar visitor teaches us something new about cosmic chemistry. For the trajectory alignment, sample size and selection bias, we have only discovered a handful of interstellar objects. Our detection methods are biased toward objects that pass close to Earth. Objects with ecliptic-aligned trajectories are more likely to encounter inner solar system planets, and therefore more likely to be discovered. Statistically, it's not as surprising as it first seems, and for the mass trajectory inconsistency, Maybe 3i Atlas is just weird. Maybe it's a fragment of a planetary collision in another star system. High density, low volatility, outgasses differently than our local comets. We're learning that interstellar space is full of diversity. Maybe we just need to expand our models. Here's the thing about natural explanations. Each anomaly, taken individually, can be explained by natural processes. Unusual, yes. Requiring specific conditions, yes. But possible. The question is, what are the odds that all 7 anomalies happen to occur in the same object, at the same time, in a configuration that just happens to look suspicious? Is it 7 coincidences, or one design? But there's another factor we haven't discussed yet, a human factor, because sometimes the anomaly isn't in the data. It's in the way we look at the data. Social media is exploding. Leaked claims are spreading. And in the chaos, cognitive traps are everywhere. Are we seeing what's really there, or what we want to see? That answer is coming. Let's talk about what happened while scientists were crunching numbers. Because in the vacuum of official data, something else was growing. Twitter, Reddit, YouTube, Discord servers, Telegram channels, a wildfire of speculation. And here's where things get messy. On May 29th, a user claiming to be a contractor at the Jet Propulsion Laboratory posted a thread stating they had seen imaging data that doesn't match any known cometary profile. The post was deleted within hours. On June 2nd, a blurry photograph appeared on 4chan, allegedly showing a printout of a high-rise image. The thread claimed NASA was sitting on proof and refusing to release it. Was the photograph real? Impossible to verify. The metadata was stripped. The resolution was too low to authenticate. On June 7th, someone claiming to have insider knowledge posted a detailed description of 3i Atlas as a cylinder approximately 200 meters in length, showing no natural fragmentation patterns. Now, before you decide whether to believe any of this, let me introduce you to 3 concepts that every critical thinker needs to understand. Number 1, pareidolia. This is the tendency of the human brain to see patterns, faces, structures in random data. It's why we see faces in clouds, animals in ink blots, the man in the moon. It's not stupidity, it's survival. Our ancestors who were quick to spot predators in the shadows lived. Those who didn't became lunch. But in astronomy, in low-resolution imagery full of noise, pareidolia is dangerous. Number 2, confirmation. Bias. Once you believe something might be true, your brain becomes a filter. It highlights evidence that supports your belief and minimizes evidence that contradicts it. If you want to believe 3i Atlas is a probe, every blurry pixel looks like a whole panel. Every anomaly looks like evidence. If you're convinced it's natural, every strange behavior looks like a gap in our understanding that will eventually be filled. Neither position is automatically correct, but both are human. Number 3, the avalanche effect. When one person makes a claim, and another person amplifies it, and a third person adds details, and a fourth person creates a diagram, you don't have 4 independent sources. You have one claim echoing through a chamber, and by the time it reaches you, it feels like consensus. It feels like multiple witnesses confirming the same thing. But trace it back, and you find a single source. There was a viral post claiming that remote viewers had confirmed the cylindrical shape of 3i Atlas through psychic observation. Now, look, I'm not here to debate the existence or validity of remote viewing. That's a different documentary, but what I will say is this. Remote viewing claims are not scientific evidence. They're not verifiable. They're not falsifiable. They can't be cross-checked with independent instruments. Are they interesting as cultural phenomena? Absolutely. Should they influence our interpretation of telescopic data? No. Here's the uncomfortable truth. When something extraordinary is happening, when we're dealing with genuine uncertainty, our minds crave certainty. We want answers. We need explanations. And into that hunger, rumors flow. Some are deliberate disinformation. Some are innocent misunderstandings that snowball. Some are genuine leaks that get distorted as they spread. Your job, as a critical thinker, is to ask, what's the source? What's the evidence? Can it be verified? Because here's what's about to happen. We're about to get a second look at 3i Atlas. Different angle, different instrument, independent verification. And if the anomalies persist, we're not dealing with artifacts anymore. Science has a brutal way of settling arguments. You make a claim, someone else checks your work. You see an anomaly, someone else looks from a different angle. In early June, something critical happened. Ground-based observatories in Chile and Hawaii, coordinating through the International Astronomical Union's Central Bureau, conducted synchronized observations of 3i Atlas. Different telescopes, different geographic locations, different atmospheric conditions, different processing software. If the elongation seen in previous images was just an artifact, these independent observations would show a normal cometary coma. If it was real, it would show up again. The results came in on June 9th. Here's what we know. The Chilean observations, using adaptive optics to compensate for atmospheric turbulence, showed asymmetry. Not a perfect sphere, not a classic coma. An elongated structure with a length-to-width ratio of approximately 2.8 to 1. The Hawaiian data, processed independently using different algorithms, showed a similar elongation, ratio 2.6 to 1. Now, does this prove the object is cylindrical? No. Could it still be an artifact? Possibly. Different instruments can make similar systematic errors, especially with faint objects. But here's what changed. The consistency across independent observations moved this from probably an artifact to something that needs explanation. Either there's a systematic bias in how all ground-based telescopes image faint, moving objects at this distance, or 3i Atlas genuinely has a non-spherical geometry. And if it's the latter, we need to talk about what that geometry means, because there's a problem, a big problem. Comets are rubble piles. They're loosely bound collections of ice and rock, held together by weak gravity and frozen ices acting as glue. When they form, they naturally collapse into roughly spherical shapes. That's what gravity does. Can they be elongated? Sure, tumbling can create some asymmetry. Outgassing can erode preferentially. Impacts can deform them. But a length-to-width ratio of almost 3 to 1, that's unusual. That requires either formation conditions we don't understand, or structural integrity beyond what loose rubble can provide. Now, add the other anomalies, the chemistry, the trajectory, the polarization. Are we looking at a natural object that's teaching us we don't understand comet formation as well as we thought? Or something else? But images alone can't answer that question. To know if 3i Atlas is under intelligent control, we need to watch it move. And that's where the calendar comes in. Physics doesn't do secrets, it does consequences. And over the next 97 days, 3i Atlas is going to leave consequences we can't miss. Let me show you the timeline. August 19th, 2024. Perihelion. This is the moment 3i Atlas passes closest to the Sun. 0.79 AU. Approximately 118 million kilometers. At that distance, solar radiation intensity is nearly twice what we experience at Earth. If 3i Atlas is a natural comet, we expect brightening. Outgassing should increase. The tail should become more prominent. If it's something else, this is where it gets interesting. Because if there's any kind of technology encased in ice, perihelion is when that ice starts to sublimate away. Any solar panels, they'd start generating power. Any instruments that need warmth to function, they'd activate. Any trajectory adjustments that require energy, this is when they'd happen. Perihelion is a furnace. It's a revelation machine. Heat elicits confessions. September 7th. Emergence from solar conjunction. For approximately 3 weeks around perihelion, 3i Atlas will be too close to the sun in the sky for ground-based observation. The glare makes it invisible. It enters behind the sun on August 10th. It emerges on September the 7th. What happens in that blackout? We can't see. But when it emerges, the trajectory will tell us everything. See, trajectories are predictable. Gravity is math. We can calculate exactly where an object should be based on its pre-perihelion path. If 3i Atlas emerges exactly where the models predict, it followed a purely gravitational path, natural. But if there's a deviation, even a tiny deviation, a fraction of a degree, a few thousand kilometers off the predicted position, that's a non-gravitational acceleration, and we'll need to explain it. October 3rd. Closest approach to Earth, 0.51 AU, approximately 76 million kilometers. At this distance, every major observatory on Earth can get high-resolution data. Spectroscopy, photometry, polarimetry, radar. If there's anything unusual about this object, this is when we'll know. November through December. Planetary encounters. Its trajectory, if it maintains its current path, will bring it past Venus in late November. Another opportunity, another angle, and if its path has changed, if those trajectory deviations compound, then we're not watching a comet anymore. We're watching something navigate. So how do you track this? JPL Horizons. It's a free online tool. You can input 3i Atlas's designation and get its predicted position for any date and time. Compare the predictions to actual observations. If you have a telescope, take your own measurements. Submit them to the Minor Planet Center. You can participate in this, because if something extraordinary is happening, it won't be one astronomer who proves it. It'll be a network. Professionals and amateurs working together, comparing notes, checking and double-checking. Truth emerges from consensus, not authority. But let's talk about what we're actually looking for. Because there are two scenarios playing out right now, and they lead to very different futures. Imagine two futures, two possible explanations for everything we've seen. Let me walk you through both. Scenario 1. The stressed comet. 3i Atlas is a natural interstellar comet, ejected from its home system millions of years ago by gravitational interactions. Its unusual chemistry, a product of formation conditions in an alien stellar nebula, different star, different composition. Its elongated shape, the result of tidal stresses during a close encounter with another object before it entered interstellar space. The sunward glow, large ice fragments, specific geometry, nothing more. As it approaches perihelion, we expect increased brightness, visible outgassing jets, tail development following standard comet models, possibly fragmentation. Comets under thermal stress can break apart. We've seen it happen. If 3i Atlas fragments near perihelion, that would actually support the natural explanation, because technology doesn't shatter when it gets warm. In this scenario, when it emerges from solar conjunction in September, it's exactly where the models predict. No trajectory deviations. No anomalies that can't be explained by outgassing. The mystery dissolves. We learn something about cometary diversity. We refine our models. Science marches on. Scenario 2. The encased probe. What if, and stay with me here, what if 3i Atlas isn't just ice and rock? Imagine a technology designed for interstellar travel. It needs to survive millions of years in the void. Radiation, micrometeorite impacts. The cold. How do you protect it? You encase it. In ice, in rock, natural camouflage, natural shielding. It looks like a comet because it's designed to look like a comet. As it approaches perihelion, the outer ice begins to sublimate. The protective shell erodes. What's underneath? We don't know. But if there are systems that need solar power, this is when they activate. If there's a mission profile, a programmed sequence, perihelion might be the trigger. In this scenario, when it emerges from solar conjunction, It's not where the gravitational models predict. There's a deviation, small but measurable, a course correction. Its trajectory has changed in a way that natural outgassing can't explain. And if that happens, everything changes. Now, before you commit to either scenario, let's be absolutely clear about something. Both are speculative, both make assumptions. Both are trying to explain data that genuinely doesn't fit our standard models perfectly. The natural scenario requires us to believe in several unlikely coincidences happening at once. The artificial scenario requires us to believe in something we've never confirmed. Technology from another civilization. Which is more likely? That's the wrong question. The right question is, what would it take to prove either scenario? What evidence would be so compelling, so undeniable, that even the hardest skeptic would have to nod? Let's talk about proof. All right, let's get specific. Because claims require evidence, and extraordinary claims require, well, you know the rest. Here are the 4 types of evidence that would constitute genuine proof of non-natural origin. Pay attention. This is your toolkit for the coming months. Proof. Type 1. Persistent, resolved structural geometry. If multiple independent observations, using different instruments and viewing angles, consistently show a structure, not just elongation but clear geometry, panels, seams, protrusions, symmetry that can't be explained by natural processes. That would be compelling, but it needs to be persistent, not a single image, not an artifact that appears with one telescope and vanishes with another. Multiple confirmations, different observers, different wavelengths, consistency is key. Proof type 2. Coherent radio emission. Natural objects emit radio noise. Lightning in planetary atmospheres, magnetic field interactions, random, chaotic. But if 3i Atlas starts emitting a radio signal with structure, a pattern, a repetition, a frequency that's not randomly scattered, especially if it's at meaningful frequencies like the hydrogen line, 1.42 gigahertz. That's not natural. And here's where you come in. Amateur radio astronomers can monitor this. Software-defined radios. Satellite dishes repurposed for radio astronomy. There are coordinated listening campaigns being organized right now. Discord servers, subreddits, open-source data repositories. If there's a signal, we'll find it together. Proof. Type 3. Trajectory changes. Irreconcilable with outgassing. This is the big one, because trajectory doesn't lie. Comets can deviate from purely gravitational paths. Outgassing creates thrust. We can model this. But outgassing thrust has characteristics. It's tied to solar distance. It's tied to rotation. It's continuous and gradually decreasing as volatiles deplete. If 3i Atlas shows a trajectory change that's discrete, sudden, not correlating with brightness changes or outgassing activity, or if the direction of the thrust doesn't align with the sun, we're out of natural explanations. That would be proof. Proof type 4. In situ data. This one's for the future, but imagine. A rapid response mission. A spacecraft that intercepts 3i Atlas, gets close, takes high-resolution images, measures composition directly. The European Space Agency has concepts for such missions. Comet Interceptor is launching in 2029, designed to target pristine comets on their first pass through the inner solar system. Could a similar mission be redirected to 3i Atlas? Maybe, if the anomalies persist. If the case becomes strong enough, that would give us definitive answers. But that's years away. For now, we have telescopes, we have radio dishes, we have math, and we have a question. Are we willing to look at the data objectively? Can we hold two competing ideas in our heads simultaneously without letting bias decide the answer before the evidence is in? Because this isn't just about one object. It's about what happens next. Let's zoom out, way out. Because whether 3i Atlas is natural or not, the impact of this moment goes far beyond one comet. If it's natural, We're entering a new era of astronomy. The Vera C. Rubin Observatory, coming online in 2025, will discover thousands of objects like this. Interstellar visitors, messengers from alien star systems. Everyone will teach us about planetary formation, stellar evolution, the diversity of cosmic environments. We'll need new models, new catalogs, new understanding of how planetary systems work. But if it's not natural, then SETI becomes SETA. Search for extraterrestrial intelligence becomes search for extraterrestrial artifacts. We stop just listening for radio signals from distant civilizations and start looking for their technology passing through our neighborhood. And that changes everything. Funding priorities, international cooperation, planetary defense protocols get a whole new dimension. Markets react, defense budgets shift, space agencies rethink mission priorities. And then there's the cultural impact, confirmation of extraterrestrial technology, even unmanned, even ancient, even just passing through. That's a threshold. It changes how we see our place in the universe. It changes philosophy, religion, politics. Some people will be excited, vindicated, ready for first contact. Others will be terrified, unprepared, demanding answers from governments that might not have answers. And this is why slow, sober, rigorous science matters more than ever. Because if the announcement comes too early, based on incomplete data, misinterpreted images, speculation instead of proof, the backlash when it's debunked destroys credibility. But if the announcement comes too late, if agencies sit on compelling evidence out of fear or uncertainty, trust erodes. Conspiracy theories flourish. We're walking a razor edge. But here's what gives me hope. Science is self-correcting. It's messy. It's slow. It argues with itself. But eventually, it converges on truth. And we're watching that process happen in real time. Every observation, every peer review, every debate between researchers. This is how discovery works. But there's one last thing we haven't discussed. The one image that matters most. And it's not on any telescope. Remember where we started? This image. This single frame that launched 1,000 theories. Now that you've seen the evidence, the arguments, the counter-arguments, the timeline, the stakes, what do you see? Is it a blurry pixel that means nothing? Or is it the shadow of something that changes everything? Here's the truth. I don't know, and neither do you, and neither does anyone, yet. But here's what we do know. We know there's an object out there that doesn't fit our models perfectly. We know it's exhibiting behaviors that require explanation. We know that over the next 97 days, it's going to pass through a crucible that will test every hypothesis. And we know how to tell the difference between proof and speculation. You're not helpless in this. You're not just a passenger watching from the sidelines. You can observe. You can contribute. You can join the networks of amateur astronomers tracking this object every night. Light curves, astrometry, radio monitoring, open data repositories. Links are in the description, because if something extraordinary is happening, it won't be one institution that confirms it. It'll be all of us, checking each other's work, demanding rigor, insisting on proof. In the coming weeks, watch for 3 things. 1. Post-perihelion brightness and trajectory. Does it behave like a comet under stress, or something else? 2. Independent imaging confirmations. Do multiple observatories see the same structure? 3. Radio emissions. Does anyone detect a non-random signal? If none of those materialize, the natural explanation wins. We learn, we move on. If even one is confirmed beyond reasonable doubt, we're in new territory. You know what's fascinating about this moment? It's not certainty we're feeling. It's possibility. The possibility that we're not alone. The possibility that technology can survive the vast gulfs between stars. The possibility that we're living through a moment that will be in history books or debunked forum posts. We don't know which yet, and that uncertainty, that tension between wonder and skepticism, that's what makes us human. That's what makes us scientists. That's what makes us curious. New photos don't always end a mystery. Sometimes they just prove the mystery is real, and sometimes that's enough. This is part 1. When 3-Eye Atlas emerges from behind the sun on September 7th, we'll be back with new data, new images, new answers, or new questions. Until then, keep watching the skies because something is out there and it's coming closer.